Hi everyone, welcome to this lecture. So in this lecture, we will see about the origin of regression. We will discuss from where the concept of regression arises. So the concept of regression arises from the concept of a straight line. That's why regression is not a very new topic in machine learning. So this is the slope-intercept form of line from our high school mathematics. We know that the slope-intercept form of line is represented by this equation, which is y is equals to mx plus b, where m is the slope of a line and b is called the y-intercept, or it is the value of y when x is equals to 0. Now let's discuss this slope-intercept form of line in detail. Now this is my data set. Now this data set is very simple as it has only 4 samples, 1, 2, 3, and 4. It has two variables, x and y. The x variable is called input variable or independent variable, whereas the y variable is called output or dependent variable. If I want to draw a straight line or I want to plot a straight line from these two variables, I can easily do that. So when x is equals to 0, y is equals to 2. And similarly, when x is equals to 1, y is equals to 4. So by connecting these points, I can easily draw a straight line which is shown here. So this straight line is a representative of this small data set where x and y are two variables. Now it's time to find two another important elements, which are the slope and the intercept. So how to find the slope and how to find the intercept? First, we will find the intercept because it is more easy. If we see here, this is the definition of the y-intercept or definition of b. So b is y-intercept, or it is a value of y when x is equals to 0. So from this data, we can see that when x is equals to 0, y is equals to 2. It means 2 is the value of b, or 2 is the value of intercept here. Here it is denoted by b, or this is called the y-intercept. So we can see that we have easily found out the value of b, which is the value of intercept. Now it's time to find the value of m, which is the slope. Now slope is defined as the change of y with respect to x, the change of variable y with respect to x. So in this way, with the help of this table, we can also find the value of slope easily. So in order to find the change in y, I have to use any two consecutive value of y. I can use 2 and 4. I can use 4 and 6. I can use 6 and 8. So let we use last two value of y. So if I subtract 6 from 8 in order to find the change of y, and then 2 from 3 in order to change in x, in that case, the ratio will give me a value of 2. Now, slope is also 2. The intercept was also 2. Now, if I put these values here, I will get the equation of a straight line. So this is the slope-intercept form of a line, which is also a basis about the concept of a regression. That's why we are starting from here. Let's transform this knowledge of slope-intercept form of line into some real data set. So again, here I am taking a real data set, which is very small. That is, it is also it has only 5 samples, 1, 2, 3, 4, and 5. Now it has only two variables again, and one variable is experience in year, the other variable is salary in dollar. So experience in year is the independent variable, whereas salary in dollar is dependent variable, because salary is dependent on the experience. So if the experience is 0 year, the salary will be $20,000. It means if the candidate is a fresh graduate and it doesn't has any experience, its salary will start from $20,000. If the experience is of 1 year, then its salary will start from $40,000. Similarly, if the experience in year is 4, then the salary will be $100,000. So if I want to plot a scatter plot out of this data, so I have 5 points to plot. So this is my point 1, 2, 3, 4, and here is my point 5. So we can see that when experience is 0, the salary in dollar is 20,000. So we can see here, when experience is 0, the salary is 20. When experience is 1, the salary is 40. When experience is 2, the salary is 60, and so on. So these are the scatter points, and this is called the scatter plot of this data set, where we have plotted salary against the experience. That is, we have plotted dependent quantity against the independent quantity. Now, let's draw a line to connect these points. Now, this is a very important slide, and there are a lot of information which I have to discuss with you about this slide. So the first important point is that we have connected these dots or these data points with a straight line. When we connect these data points with a straight line, now it is not only a straight line, it is our linear model. When we say linear model, basically by drawing a straight line, we have uh, trained a linear model on these points. How it has been trained and what it has learned and how it will benefit us. So we have to discuss all this in this slide. So basically, if I go back to the previous slide, I had only 5 data points. So this is called the scatter plot of these data points. When I join these data point with a straight line here, so basically this is not only a straight line, but it is also a linear model. By drawing a straight line on these points, basically I have trained a linear model. Now this linear model is trained and now it is going to benefit us. Now discuss a few more things before we see how it is trained and how it is going to benefit us. Now here x is experience is air or it is an independent variable. The salary in dollar is our dependent variable for this example. Now the slope is 20,000 and intercept is also 20,000. You can see the intercept is the salary value when the experience is 0 or when the x value or when the independent variable is 0. So you can confirm from here, this is our intercept. Similarly, you can easily find the slope by taking the two consecutive y quantity and the x quantity. So the slope is also 20,000. Now I want to convert this equation of slope intercept form of line with respect to this real salary data set. Now y is salary, m is my slope, x is the experience, and b is intercept. So we have transformed this data set into a new equation with the help of slope-intercept form of a line. Now, again, the important thing is, if you see this straight line as a mathematics student, this is only a straight line. But if you are looking this line as a machine learning practitioner, so this is not only a straight line, but it is a linear model which has learned something. So what it has learned? It has learned the relationship between x and y. That is the relationship between the independent variable and the dependent variable. How it has learned the relationship? Basically, it has learned that when the experience is 0, salary is 20,000, and when the experience is 4 years, the salary is 100,000, and it also has learned all the values between them. So by drawing a straight line on the data points, it means you have trained a model and it has learned a linear relationship between the independent variable and dependent variable. Now, this straight line is also known as our linear model. So here is the straight line. Now, this is not only a straight line, it is a linear model because it has learned a linear relationship between the independent variable and the dependent variable. Now, what is the proof that it has learned something? Now, it has learned, now it is going to benefit us. Suppose a candidate comes to us whose experience is only 1.5 years. Now, this value 1.5 is not present originally in our dataset. But since we have trained a model on this dataset, now this model, which is a straight line and which is also known as linear model, will help us to find the salary of a person whose experience is 1.5 and this value is not present originally in the dataset. So now this is the testing point for this linear model. Now I am supplying 1.5 year to the model here, and here model is giving me the prediction. So model is telling that if the experience of a candidate is 1.5 year, its salary should be 50,000. Similarly, if another candidate comes to us whose experience is 3.5 years, now this model will help us to find the salary of that candidate. Although this 3.5 is not present in the training data, but since this model has learned the linear relationship between the independent and dependent variable or between the experience in years and salary in dollars, now it is going to find the value of salary for any experience in years. So if a candidate comes to us whose experience is 3.5, so I will give this input to my model. So this is my testing point. So when I will give this input, it is giving me the prediction. So we can see that it is suggesting that the salary of the candidate whose experience is 3.5 year should be equals to $90,000. So in this way, we have seen that this is our linear model, and it has learned a linear relationship between the x value or the independent variable and the y value or the dependent variable. So this is the definition of a linear model. So the linear model establishes a linear relationship between a dependent variable and an independent variable. So this model has learned a lot about the experience in year and salary in dollar. If a person comes whose experience is 10 years, even then we will be able to find its salary with the help of this linear model. In that case, since we know the slope of this linear model, we will extend this linear model further to a value where it reaches to a point where the experience is 10 years. And in that case, we will be able to find the salary of a person. So student, in this way, we have learned that a straight line which is connecting the points is not only a straight line, but it is a simple linear model which has learned the relationship between the x quantity, that is independent variable, and the y quantity, which is the dependent variable. After training this straight line model or a linear model, we can take help from this model by giving any input, so it will be able to predict the output. So this model has established a linear relationship between a dependent variable and an independent variable. So till now, we have learned this. We have trained our linear model on a training data. We have X, we have Y, and we have trained our linear model on this data. So after training, when we give a new sample to this linear model, which is not present in our training data, that is when we pass a test sample to our trained linear model, it is able to give us the prediction. So in this lecture, we learn about the origin of the regression. We see that the origin of the regression comes from the concept of a straight line, and the concept of the straight line basically gives the concept of a linear model. A straight line is not only a straight line, it is a linear model which establishes a relationship between a dependent and independent variable. And it learns this relationship, and after learning, this straight line is able to help us to give the output with respect to any input value. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.